in the second module, we have some of the remaining topics to be taken, right? So, which was the consistency of clay, which I taken the theory part, that is liquid limit, their test, um plastic limit, shrinkage limit, etc. So, next we have a shrinkage parameters. Okay, shrinkage index. Okay, so it is a numerical difference between liquid limit and shrinkage limit. That is, IS is equal to WL minus WS. Okay, shrinkage index. Then it is the shrinkage ratio. Next one. What is shrinkage ratio? It is the ratio of a given volume change expressed as percentage of dry volume to corresponding change in water content. Okay, so SR shrinkage ratio is given by V1 minus V2 divided by VD. Okay, whole divided by W1 minus W2 into 100. Okay, most probably problems might be asked from this parameters. Okay, otherwise they might ask questions like define shrinkage index, shrinkage ratio, volumetric um shrinkage. Okay, there might be questions like that. So V1 is volume of soil mass at water content 1, W1, and V2 is volume of soil mass at water content W2. Okay, VD is volume of dry soil mass. Next is volumetric shrinkage, that is given by Vs, that is V1 minus Vd divided by Vd into 100. Okay, it is the volumetric change is defined as the change in volume expressed as percentage of the dry volume when water content is reduced from a given value to shrinkage limit. So V1 minus Vd divided Vd into 100. Next is linear shrinkage. Change in length divided by the initial length when the water content is reduced to shrinkage limit. Okay, this linear shrinkage is normally not asked for exams, but still you have to know about it. Okay. Next comes is the Atterberg's index, plasticity index, which is very important. It is the range of water content over which the soil remains in a plastic state. Okay, it is equal to the difference between liquid limit and plastic limit. That is IP, plasticity index. IP is given by WL minus WP. Okay. Next is liquidity index. Okay, plastic index is given by PI or IP. Okay, it is IL is equal to W minus WP divided by IP into 100. So W is the water content of soil in natural condition. The liquidity index of a soil indicates the nearness of its water content to its liquid limit. Okay, it is also known as water plasticity ratio. Okay, next is the consistency index. Okay, consistency index is given by IC. Okay, IC is equal to WL minus W divided by IP into 100. The same as it. Water content, W is the water content of soil in natural condition. The consistency index indicates the consistency of a soil. Okay, it shows the nearness of water content of soil to its plastic limit, whereas in liquidity index it is nearness of water content to its liquid limit. Okay, next is the flow index. Flow index, if you remember, I've explained the Casagrande test, right, where number of blows will be given, and then you measure the small scoop. There will be a small scoop, and you trim that in the middle, and you take the water content, etc. Okay, you can read or like study it in the it is there in the KTU notes. Okay, the procedure, you can just go through it. There sometimes there might be a problem regarding it, and I'll be explaining one of them in the class. Okay, so flow index, it is the slope of a flow curve obtained between the number of blows and water content in Casagrande method of determination of liquid limit. Okay, IF is given by W1 minus W2. We'll take 2 water content from that, and then log divided by log to the base 10 N2 by N1. Okay, where N1 is the number of blows required at water content W1, and N2 is number of flows required at water content W2. Okay, so this is how the graph is. N is number of flows, and W is the water content. You randomly take two water contents here, okay, corresponding values to the number of flows. Okay, I think you will be better. It will be better explain the problem. Okay, next is the toughness index. So toughness index IT is given by IP by IF. Okay, ratio of plasticity index to flow index. Okay, next is application uses of consistency limit. So you can just go through it. Okay, I'll explain a problem. A soil has a liquid limit of 25% and flow index of 12.5%. Okay, if PL is 15, plastic limit is 15%, determine plasticity index and liquidity index if the water content of the soil, water content of the soil in its natural condition field is 20%. Find liquidity index and relative consistency. Okay, so what we have? Okay, liquid limit is given, right, 25%, and flow index is given 12.5%. Then what is given? IP. So what is IP? IP is plasticity index is equal to, we have liquid limit minus plastic limit, right? WL minus WP. So the already the values is given. So you get 25 minus 15, you get 10%, right? Then it is the what is next? IT. Okay, it is sorry, PI and IT. Okay, this is IT. What was IT? We have explained, that is toughness index. Toughness is given by plasticity index divided by flow index, right? So plasticity index is given 10. Okay, 10 was we got from the values WL minus WP. You got a value 10 divided by flow index was given 12.5. So what you got? You got this toughness index. Okay, IT is, you found IT. Okay, then what is yet to be found? W minus WP divided by IP, that is liquidity index. You need to find liquidity index and relative consistency here. So look at the equation, W minus WP divided by IP. So first, when you solve the problem, just note down what is to be found. Okay, liquidity index and relative consistency. Just write the equation there, and then what is need to be found from that? W minus WP divided by IP. First IP should be found out, which we already got it, right? So I meant is that when you are starting a problem, just find out what is to be found out, liquidity index and relative consistency, right? Just write the equation, and what is not there, try to find that. Okay, so we have 0.2 minus 0.15 divided by 0.1, that gives the liquidity index, right? And 200 you got liquidity index as 50%. What is next to be found? Relative consistency, right? We have the equation here for relative consistency index, right? So WL minus W divided by IP, okay, into 100, that gives your relative consistency. Okay, so consistency index is, relative consistency is same as consistency index. Okay, then try to solve much more problem in that. Okay, there's a similar problem, you can try this. And then one more, a test for determination for the liquid limit was carried out on a soil sample. The following sets of observations were taken. Plot the flow curve and determine the liquidity limit and flow index. So this is, we have to find liquid limit and flow index. Okay, here number of flows is given, water content is given. Okay, we'll just rotate the graph. Okay, so we'll draw first number of blows here. Okay, and this draw water content. Okay, they have started with 40 here. Okay, we'll correspondingly plot the graph. Okay, whatever value. So we get a straight line. Okay, out of this straight line, what is the equations here? It is, I don't know whether you can read. Okay, so flow index we give if is equal to w1 minus w2 divided by log to the base 10 n2 by n1. So randomly you can take a water content. Okay, one w1 you can take here and you draw down, that is n, and then n1 w1, and then one more value you take here, you can draw it here, it is not much visible in this graph, and then you take corresponding, that you will take a random value w1 corresponding whatever number of rows you get, and you take another value as w2 in corresponding n2 will be taken. Okay, based on that you get for n25, it is normally taken in the Casagrande test. It says that you should get a number of blow, or you should get a liquid limit properly at n25, which is not practically possible. Okay, you might get number of blows as 26, 28. Okay, so where the proper curve, both there's a groove, right? We take the groove, and then we have to measure 1 point, almost around 1.2 centimeter away gap, where the gap happens of about 1.2 centimeter, the number of blows are noted. So if it is n25, you get a liquid limit as, here you can see n25, you mark n25 somewhere here, and then you take a straight line. Okay, corresponding water content. Okay, water content almost you get 50% here. Okay, for n25. Okay, whereas what was asked to find flow index, so if equal to w1 minus w2 divided by log to the base n2 by n1. Okay, so here we have taken a random value of 38 number of players, we consider as 38 as n2, and we take n1 as 27. Okay, corresponding water content is also taken. So it is 49.5 minus 47.5 divided by log 38 by 27. That is your flow index. Okay, so that's it about the plastic limit and liquid. Next is the soil classification.